manufacturing organization, which is used for marking purpose, which is used for layout purpose, and which is typically used for measurement of height and steps, which is known as a vernier height gauge. So this is a typical vernier height gauge which can be used for variety of measurement and variety of marking purpose also. It basically have a base like this. Inside this base a frame is fixed, and inside this frame a main scale is provided. Just this is the main scale, and along this beam a moving element is there, which is known as a vernier element. It have a rectangular projection like this, on which you are supposed to keep this particular thing. Now this is known as a scriber. With help of this scriber, we can use it for marking purpose as well as we can use it for measurement also. For this, a clamp is provided like this. You have to keep this clamp like this first, and then insert a scriber blade inside this. Once it comes to a perfect position, lock this into position. So now with help of this we can take measurement and we can use it for marking purpose also. While using this instrument, first of all you have to rest it on the upper face of the surface plate. Then you have to check it for 0, that means 0 of main scale is in line with 0 of vernier scale or not. And once they matches, we can use it for the measurement. So typically you have to move this scriber blade so that it will rest the component at different points like this. Point number 1, point number 2. So this indicates step number 1, step number 2, something like that also. So you can raise this and you can bring it into a particular position. This instrument typically comes with an additional feature of adjusting 0. For example, if I take a vernier and if I close the jaws of this vernier and suppose zeros are not matching, so we cannot do the adjustment of rematching these two zeros. But in case of this vernier height gauge, we have a zero error adjustment also. For zero error adjustment, this whole device is provided over here. At the back side, two knobs are there, 1 and 2. This one is known as a beam knob, this one is known as a scale knob. And from front side, again one small adjustment knob is there. So what you are supposed to do is, if suppose zeros are not matching, you have to bring it to this position, and you can move the scale by using this knob so that the zero gets adjusted. So this is how these knobs are provided. What we will do is, in one more video we will give you the details of this. That means how to adjust this zero and all these things. So now we will see how to use this vernier height gauge for taking measurement. I have bring it to the position where the scriber blade has touched the top face of the component like this, and I have make the adjustments also. That means you have to lock this screw first, do the fine adjustment, and then relock this for final position. Now we are supposed to read this. Again, in case of vernier height gauge also, the scale is provided with metric and with inch system. So we are supposed to read metric scale over here. In this case also, here scale is provided in centimeters. That means if you just look at here, 0, 1, 2, 3, 4, likewise up to 10, but it is mentioned as 1 because the scale is in centimeter. But still we can read it in mm also. For example, 0, 10, 20, 30, 40, 50, likewise up to the range of instrument. This is 30 centimeter, that means 300 mm. So range of this vernier height gauge is 0 to 300 mm with a least count of 0.2. Now when reading this vernier height gauge, what you have to do is, you have to read main scale first. That means find out that division on main scale which has been crossed by 0 of vernier. So according to this, if I start with 0, 10, 20, 30, 40, 50, 60, and division number 64 has been crossed over here. Just see this. So 0 is at this position and division number 64 has been crossed by this 0. So my main scale reading is 64 mm. To find out matching division, what I will do, I will just see the position of the 0. If I start with 0, 5, 10, this is 15, likewise up to this. If you closely observe over here, this number is mentioned as 8. So this 8 is matching with the main scale division. 8 means what? From 0 to 1 there are 5, 2 means 10, 3 means 15, 4 means 20, likewise 8 means 8 multiplied by 5, that is 48 division. So division number 40 is in line with the main scale division. So because of this, 40 multiplied by 0.2, that is 0.80 mm is the Vernier scale reading. Means here 64 is main scale, division number 40 is matching, so 40 multiplied by 0.2, that is 64.80 mm is the reading.